post-action report for test number 17. We've kind of picked out about, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11 questions. Actually 10. Looks like we've got 10 questions there that we're going to focus on. Now, what I've got is I've got my answer sheet, but I don't necessarily have a worksheet, so I'm going to do this to the best of my ability. The first question it seems that we need to go over is question number 2. Number 2. Okay, number 2 reads as this: Sam traveled m miles in h hours, then traveled n miles in 2h minus 1 hours. At his average rate, how long would it take him to travel 50 miles? All right, so we've got our distance, our rate, and our time. We start off with m miles in h hours. Okay, which would, our rate would be m over h. Okay, let's see, after that, and then, so we've got d1, r1, t1, then we're going to have d2, r2, t2. Okay, then traveled n miles in 2h minus 1 hours. Okay. Let's see, so that would be n over 2h minus 1 if we needed to use that. Okay, the question is at his average rate. So what we need to do is we need to find average rate. So average rate is overall distance over overall time. So our overall average rate should come out to m plus n over h plus 2h minus 1. Well, this can be reduced, right? Because this h plus 2h minus 1 should come out to 3h minus 1. Is that correct? I think, Ryan, this was yours, right? So simplifying this up, we should get 3h minus 1 down here. All right, so that's our overall average rate, but the question is, at the overall average rate, how long would it take to travel 50 miles? So if we're asking for how long time is distance over rate, right? So we're going to change that up so that we're taking 50 miles, I'm going to say 50 over 1, divided by my rate of m plus n over 3h minus 1, which means we're going to multiply by the reciprocal. Okay, so what we should end up with here is 150h minus 50, because we're going to distribute the 3h minus 1 to the 50 over m plus n, and that should be in hours. Okay, does that help you out a little bit? Okay. All right. From there, it looks like the next question, we had several people miss this, would be number 5. Number 5 says, use the result of problem 4 to solve y. Hopefully that was something that you guys caught in the review video, that you don't actually have to use anything from 4 to solve 5, right? Did that throw anybody off? Yeah, okay. It's just 2 linear equations that you need to solve for the y part of. Okay, you don't actually have to use, basically what they're saying is you would probably solve this the same way you would solve number 4, but you don't have to use anything from 4 to find 5. Okay, so looking at this is probably going to feel like a kind of a no-duh type thing. 2x plus y equals 7, and then we've got 5x plus 8y equals 1. And they're wanting you to solve for y, which means we need to cancel out our x's. Okay, there's a couple different ways to do this, but basically what I'm going to do here is I'm going to multiply by 5 here, I'm going to multiply by 2 here. I'm going to rewrite this after everything has been multiplied. So I've got 10x plus 5y equals 35. And down here I've got 10x plus 16y equals 2. And then I'm going to subtract the two equations. I'm going to cancel out my x's. I got 5 minus 16, which is, what, negative 11, right? Negative 11y equals 33. Divide 33 by negative 11. Y equals negative 3. That's all I need.
Because I actually didn't use what I found for y. I just said multiply 5 by 7, and I just get the 7.
Okay. Okay. All right. So hopefully that clears that up, and we see this question again, we're not going to have nearly the trouble with it that we had on this test. Okay. All right. Let's go from here to number 6. Number 6 says sketch the graph of y equals log 3x. So the way I would plug this in my calculator is log x over log 3. Okay, I should find something along this line. So anybody tell me, you know, if I didn't give you credit for this, and it definitely looks like you should have. Okay, I'm going in here, log. Clear that up. Log x divided by log 3. And we just want the graph. Okay, and a couple of things I'm looking for specifically in this is if I've got this graph here, we're looking for, granted, yours may look like this, but you gave me a table of values, and in this table of values, I should see a couple of things. I should see 1, 0, and 3, 1, right? And those should be easily found in your table of values. All right. If I looked at 1 and didn't see 0, or I looked at 3 and didn't find 1, I knew that you did something wrong. Okay. So if I pull this back up here, okay, I'm going to hit second table or second graph. You know, let's see, I got 1, 0, and I got 3, 1. Okay. If I don't have that, then you plugged something in your calculator wrong, and that's why you probably would have missed it. Okay. All right. All right, after that was what, number 7? Number 7, let's see, convert 3 minus 4i to polar coordinates, convert 7 cis to 40 to rectangular coordinates, give an exact answer. Exact answer means radical. Okay, if there's a radical in it, you have to have it in your answer. So I'm guessing, let's see, on 7 I've only got 2 people listed here. Is there a particular, who raised their hands on this one? Okay. I only seen one hand. Was it an A and B or A or B? A and B. A and B. Okay, so you missed both parts. Okay. All right, so 3 minus 4i. We want this in polar coordinates. Okay? So we're going to start off with this. We're going to go to the right 3. We're going to go down 4. Does that make sense? Okay, so to the right 3, down 4. In polar coordinates, we need the hypotenuse and we need the angle. Okay, those are the 2 ingredients I need, right? Okay. So the first thing we need is the hypotenuse. So I can do that based upon a couple of things. I could use the Pythagorean theorem, 3 squared plus 4 squared equals c squared, right? Did you get 5 for your hypotenuse? Great. All right, so we got 5. You could do cis for that. Now we need the angle, okay? Well, we have opposite, we have adjacent. So let's use inverse tangent. Do you have a graphing calculator with you there, Haley? Let's borrow one. All right, so, and I'm going to check and see if that may be, yeah. you can actually use the -4 here. So inverse tangent -4/3, and that will give us our angle. -53.13 degrees. What was your answer?
5, 6, 36.87 degrees. Since I messed up on the first tan, I put 3 over.
You put 3/4. Okay. All right. All right. So does the polar coordinate portion of this make sense? Okay. All right. Let's call this 7A. Let's actually just go to another page for 7B. Okay. 7B. We want 7 cis 240 degrees. Okay. 240 degrees is going to put me in the third quadrant, right? So I'm down here. I know that this is a 7, correct? 240 degrees is going to give me what for my reference angle? How many degrees past 180 am I? 60. Okay? So what's nice about this is that, yes, we can use sine and cosine to find our negative x and our negative y, but because it's a 30, 60, 90, I actually don't even need to do that, okay? Because what's opposite of 30 is going to be my x, and because it's a 30, 60, 90, right, my 30 side is half of my hypotenuse, so I should get -7 divided by 2, right? Does that make sense? And then over here for my y, that's my opposite of 30 times radical 3, right? So what I should get is -7 radical 3 over 2i. And what's nice about being able to do that based upon the 30, 60, 90 is if I go ahead and I put that in my calculator, what I'm going to wind up with is I'm going to wind up with an irrational decimal for the I portion. Okay? So we want to recognize that from the 30, 60, 90 side, okay? Does that help? I'm guessing there might be some other people that... I also I took -3.5, and I took -3.5 radical 3i on that. Okay, if you turned that -7/2 into a decimal. Okay? All right, what do we have after that? We had number 9. Okay. Number 9. Okay. Number 9, find the range, mean, median, mode, variance, and standard deviation of the following data. Whose question was this one? Somebody raise their hand on number 9. They raise their hand on 9. Because if I can narrow this down to what particular part. Okay. So variance. Variance is the part that you missed. I think, all right, so did you get the standard deviation?
Yeah.
What was your standard deviation? Okay. So what did you do with the standard deviation in order to find your variance?
Divide at 9 by 2.4.
Okay, so that's what I want to get to. In our variance is equal to our standard deviation squared. So we're going to take 2.94 and square that. All right, what is that? What's 2.94 squared?
8.64.
Should come out a little closer to 8.67, but 2.94 squared.
It says 8.6426.
Okay. Well, I mean, I would probably even still take that. 8.64. I probably would still have accepted that answer because you'd been, what, 3/100ths off. I'm probably not going to count that. Okay? So does that clear that up for you?
Yeah.
Yep. Okay. Let's see. 10. 10 is the big one. Okay. 10 is the one that over half our class missed. 10. Let's see. Now, of the 5 people who raised their hand, how many of you just missed A? Okay. Actually, we'll probably just need to hit all of it, right? All right, so let's look at A. I'll do my best just to kind of draw this if I can. On this, it says write the equation of part A as a sine function, right? So if I'm looking at this, it's what's nice about it is that it's already cutting through, going through something like that. Let's see, it has a peak of 19, has a minimum of negative 23. Okay, and we notice here that it cuts through at 120 degrees. All right, so let's start here with our center line. What's the center line between 19 and negative 23? Negative 2. Okay. Our amplitude is probably not even one that we really miss too much. It already looks like a sine function, right? And as it crosses through the origin, right, we're looking for positive or negative amplitude based upon how it crosses through that origin. Is it crossing through the origin going up or down? Down. So we're going from negative 2 to negative 23. So my amplitude is what? Negative 21. Okay? All right, negative. All right, we know that our function is going to be as a sine function, and it looks like from the graph that they gave us that they're going to use theta, right? All right, the next thing that we're looking for is a period change. All right, so we're looking at how many degrees does it go through a complete cycle, right? Complete period. Right, notice that it goes through and finishes its period in 120 degrees, right? So what we want to do, right, is we want to find out what that is as a fraction, okay? So we want to find out how many periods it would go through in 360 degrees. So we're going to take 360 divided by 120. What's 360 divided by 120? 3. So period change is 3. And because they wanted it as a sine function and it looks like a sine function, is there a phase shift involved? No, there's no phase shift. Okay, so phase shift, nothing there. All right, so my equation is written as negative 2 minus 21 sine 3 theta. Okay? So I think the part that most people missed was the period change. Okay, and I even had people throwing in a phase shift when there wasn't one. Okay, because we're so used to we've worked on phase shifts and then we get a test question that actually goes back and doesn't use one. We're expecting to see one, and so we make up a phase shift where there isn't one. Okay? All right, let's look at 10b. Okay, 10b is similar. They want this one written off as a cosine function. And if you look at it, you'll notice that it looks like a cosine function. So I can tell you off the bat that there's no phase shift here. Okay, they want it as a cosine function. It looks like a cosine function. There's no shift. Okay, so it's going to look like this. Okay, has a peak at 10, has a minimum at 6, and it appears to be completing, let's see, a cycle here at 80 degrees. All right, let's see if we understand this one a little bit better. All right, so what is our center line? What's between 10 and 6? 8. Okay, our amplitude, does it appear to be positive or negative? Negative. All right, so if we're at 8, we're going down to 6. My amplitude is what? Negative 2. Okay, our function is cosine. I believe they're using theta for this as well. Okay, period change. Okay, what am I doing here to find my period change? 360 divided by 80. Okay, what's 360 divided by 80? Give it to me as a fraction. Okay, probably going to be 9 halves. 9/2. So my period change is 9/2. There is no phase shift, so now we're just ready to write y equals 8 minus 2 cosine 9/2 theta. And I probably would have taken 4.5 theta. Okay. Was that easier than what we were making it out to be? Okay. All right. Let's see, number 11. Number 11. Simplify. Okay. Let's see. We've got 9 ln squared plus 4 to the log base 4 6 minus log base 4 2 minus 7 log base 7 21 plus log base 7 1. Okay, so the first thing that I'm going to do is I'm going to take this 2 here, move it out front. That's going to become 18. L in E is just 1, so that's 18 times 1. Does that make sense? You can go with me there. All right, when I've got 4 to the log base 4, basically I'm cutting this down to the 6 divided by 2. All right, what's 6 divided by 2? 3. Okay, over here, minus, so what I'm looking at here is 21 times 1, which is 21. So I have 18 times 1 plus 3, 18 plus 3 minus 21. 18 plus 3 is 21. 21 minus 21 is 0. Okay, should have come out to 0. Questions about that? Okay, no, nothing. Okay, number 12. Number 12, multiply. Express your answer in rectangular coordinates. 5 cis negative 70 degrees. Okay, 3 cis 280 degrees. All right, what do we do with the hypotenuses? Hypotenuse? Multiply them. So I've got 15. What do I do with the degrees? Add them. What's 280 minus 70? 210. Okay. From there, I should be able to graph that. 210 degrees is going to be 30 degrees past 180. Is that correct when you see that? All right, my hypotenuse is 15. From there, I'm following my 30, 60, 90 stuff, right? I don't even have to use sine and cosine, although I could if I needed to. But because they want our answer, what do they say there? They want an exact answer, so they want things with a radical. All right, so I should get 15 divided by 2 here, right? And I should get 15 radical 3 divided by 2 right there. Both of these are going to be negative. Okay, this is where I would have accepted, let's see, 15 divided by 2, is that 7.5? So I would have accepted that negative 7.5 minus 7.5 radical 3i, but the preferred way of looking at this is negative 15 divided by 2 minus 15 radical 3 divided by 2i. Those would be my rectangular coordinates. Okay, we okay there? Okay. Let's see, what was that? Number 12 brings us to 19. Solve the equation below, given that we're between 0 and 360 degrees. 19, whose was 19? All right, is it an A and B or an A or B?
A and B.
A and B. Okay. So we'll start off with A here. And we have cosine 2x plus 1/2 equals 0. First thing you're going to do is subtract the 1/2. Okay, so we've got cosine 2x equals -1/2. Okay? So what we're going to do from this point is we're going to plot it. Okay? So -1 divided by 2 in a cosine function, that's adjacent over hypotenuse. So adjacent means I'm going to go to the left 1, okay, with a hypotenuse of 2. So I should see something either here with -1 and 2, or down here with a -1 and 2, right? Which means this would be radical 3, this would be radical 3, right? Okay? All right. So with that being the case, this reference angle is 60 and this reference angle is 60. But what I'm looking for are at what degree does that show up? So this should be 120 degrees, correct? All right. And then we want to go 60 degrees past 180. So that would be 240 degrees, right? Okay. So with that, what we're saying is that 2x, because we've already done the cosine. What we're saying is 2x so far equals 120 and 240 degrees. Okay, but we want x, so we're going to divide those by 2. Okay, so we should get 60 and 120, which means we have room to keep going around, right? So we're going to take 120 plus 360. Okay. What is that?
480.
480. Then we can come down here and we can divide that by 2 and we're going to get 240. 240 plus 360 is what? 600, which is going to leave us with 300, right? All right, now the last thing that we need to do, and I probably would have given you half credit on that because if you'll notice that it does want it in radians. So we're going to take 60 divided by 180 and get the fraction. Can you do that for me? Actually, I might be able to. You should get like 1/3.
Yeah.
All right, so we should get pi over 3. For 120, we're going to get 2 pi over 3. For 240, we're going to get 4 pi over 3. And for 300, we should get 5 pi over 3. Okay, but just to kind of save us the time in calculating that, all we're doing is dividing those by 180, hitting math fraction, and setting up with a pi in the numerator. Okay? So does that help out on A? All right, let's look at 19b. Okay, 19b. All right, we got radical 3, tangent x plus 1, 2 sine x minus radical 3. All that equals 0. So what we're going to do is we're actually going to take these individuals and set them equal to 0. So radical 3 tangent x plus 1 equals 0. So subtract 1 and divide by radical 3. Tangent x equals -1 over radical 3. You follow me there?
Yeah.
Okay. So I'm going to stop right there with that guy. Okay, and go ahead and plot this. Tangent is opposite over adjacent. And so opposite, you could also look at it as sine over cosine. But in order for that to be -1, it's going to have to drop below, right? And for it to have a positive, actually, we could still have it in 2 locations. So we should be here or here. We're going to have, actually, no, hold on a second. We'll get one at a time here. Okay, so we've got -1, positive radical 3. Okay, and then what we can have is we can have this guy here where we have positive 1, negative radical 3. Okay, well, based upon these, we can tell we've got reference angles of 30 here and 30 here. We're going to look at where those show up at. This one should be at 150 degrees. This one down here should be at 330. Does that make sense?
Yeah.
Okay. And we understand why we get both of these locations based upon -1 over radical 3, because the fraction works out the same in both places. Okay? All right. So what we're going to do is we're going to take, because it's just tangent x, we're not dividing by anything or multiplying by anything. We're going to take 150 divided by 180 and get our fraction. Okay, what's 150 divided by 180? Okay, so we got 5 pi over 6, and then we need 330 divided by 180, and I think you're going to end up with 11/6. Okay, so that works for that one. We get 5 pi over 6, 11 pi over 6. Let's come to the next one, which is 2 sine x minus radical 3. We're going to add radical 3, divide by 2, so sine x equals radical 3 over 2. Okay, we are opposite over hypotenuse. Let's see. Radical 3, 2. Radical 3, 2. 1, -1, 60 degrees, 60 degrees. Right, we've been in these positions before, so we've got sine x equals 60, and sine x equals 120. Okay, we'll just convert those. What we should get again is pi over 3 and 2 pi over 3. Okay, hopefully those make a little bit more sense. All right, last question, number 20. All right, who all did we have here? Had about 3 people. Okay, so we've got kind of an odd looking triangle here, 150 degrees, 20 inches, and 50 inches. And it says find the area. Well, how do I find the area of a triangle? Base times height divided by 2. All right, what is our base in this triangle? 20, okay? Our base is 20. We know we're going to have the 2. What we're trying to solve for is the height. So what we're going to do, our height is our perpendicular line from the base to the opposite vertex. All right, so sometimes that height line exists outside. So hopefully you didn't use 50 for the height. Okay, but I'm guessing that's probably the mistake that would have gotten used, was using 50. Okay, but 50 is not perpendicular to my base. Okay, so at this point, I'm going to create this outside triangle. It's going to be, we've got a linear pair here, so 30, and we're looking for height, and basically 50 becomes the hypotenuse now. Does that make sense? Okay, so we want to find height, so we're going to use sine. We're going to use sine 30 equals h over 50. So we're going to use 50 sine 30. So if we want to put this in here, we would do 20 times 50 sine 30 divided by 2. So if I want to plug all this in my calculator in one shot, okay, 20, and we got 50 sine 30 divided by 2, and I get exactly 250 inches squared. Does that help you out? Hopefully a little bit. All right. Are there any other questions? Anything that needs to be gone back over? Is there anything that you feel like needs to be changed in your test? a place where you got everything taken off, you feel like you should have only gotten half, or you got half taken off, you feel like you should have gotten whole. Anywhere where it looks like I might have made a mistake in grading your test. Because I want to fix that if I can fix it. Believe me, I do not consider myself to be foolproof. Looking through these things, I am capable of mistakes. If you don't understand why you missed something, particularly at like places where it might get a little iffy and hard to determine, are questions like question number 13, even number 6. There were places where I saw people forget a couple of things. Like on question number 15, I saw people forget the mean or the standard deviation. You might have forgotten something in number 9. For the most part, like I wasn't wholly displeased with your test. So anyway, okay. Well, I'll close it off right here then.